Now we'll have a look at this example here, and we're given our length kg drafts forward and aft, and we need to determine the maximum trim to enter dry dock if the GM at the critical instant is to be not less than 0.2 of a metre. We always have to assume km is constant when we get the value that we do at the critical instant, because we're going to use that throughout. Well, we're already trimmed, but the question is actually asking us for the maximum trim if the GM is to be not less than 0.2 of a metre. So how do we solve this problem? Okay, well, if we look at our formula for P to work out the P force, P is trim times MCTC over LCF. And that's the value we're looking for, trim. Well, MCTC and LCF, of course, we can look up with our true mean draft. And if we can then get P, then we can solve the problem. So how do we get P? Well, the formula for virtual loss of GM is P times Km over the displacement of the vessel. So if we transpose that formula around, we can get the P value. Once we've got it, of course, we can then put it into the formula and work out the trim. So we've got to use both formulas, but we're sort of doing it backwards, if you like. However, always initially we have to work out our true mean draft. So there's our drafts forward and aft, get the average mean draft, go into the tables, get the LCF, calculate our true mean draft, which is after draft plus or minus LCF times LBP over trim. Of course it's minus because we're trimmed by the stern. The amount we take off, 5.52, gives our true mean draft 4.729. Go in the tables, displacement, Km, LCF, MCTC. Pick those four values out. Our Km we've got to assume is constant to solve a problem like this. So the Km is 9.19. We're told our kg 8.78, which isn't going to change because of course our displacement isn't changing. So before we start, if you like, or at the critical instant, initial GM is 0.41. The minimum at the critical instant is to be not less than 0.2. So in effect, the virtual loss of GM is 0.21. So for this situation to prevail, for our minimum critical GM to be 0.2 at the critical instant, our virtual loss has got to be 0.21. Virtual loss of GM is P times Km over W. Well, we've got the virtual loss of GM, we've just got that. We've got the Km and the weight, both from the tables. So let's move the formula around and work out P. And that's how we do it there, and we end up with P of 217 tonnes. Well, we've got the value of P now, and we know that P is trim times MCTC over LCF. Well, we're looking for trim, so let's transpose. Trim is P times LCF over MCTC. We've got P, we've just calculated that. LCF and MCTC we got from the tables. So we found that P is 96.3, trim is 96.3 centimetres. So our answer will come out in centimetres because of course we've used our MCTC. So the maximum trim is 96.3 centimetres, or another way of saying it, 96.3 centimetres by the stern. So that's how we would solve the first one. So if we wanted to enter the dry dock and have a GM at the critical instant of 0.2, then our trim to start with must be 0.963 by the stern. The second part asks us to calculate the weight of ballast transfer from the aft peak to the fore peak in order to reduce the trim to the maximum allowable. So what we're saying here in B, difference between our two drafts, 3.94 and 5.52, gives us our original trim of 1.58 by the stern. Well, we actually want to have a maximum trim of 0.963 by the stern. So we're changing our trim by the difference between the two, 61.7 centimetres. That's how much we've got to change our trim. And for change of trim, trimming moment over MCTC, trimming moment is weight times distance. So we have to go into the stability information booklet and look up the fore peak and after peak, their positions in relation to the after perpendicular. In other words, get the longitudinal centre of gravity of each one. And we can see at the tables the fore peak is 130.56, aft peak 3.07. So the distance between the tanks that we're actually going to have to move the liquid is 127.49. And that's the amount that we would put, 127.49, that we have to put into the table. So let's transpose the formula. The weight we're looking for to transfer is change of trim times MCTC over the distance that we've got to move, in other words, between the aft peak and the fore peak. Well, that's 127.49. We know our MCTC because we looked it up originally with our trimming draft. We know our change of trim because we've just worked that out, and which is here, which is the difference between our original trim and what our maximum trim has got to be. We put those into the table and we can see that it's 75.6 tons weight that we will have to transfer from the after peak to the fore peak, because we're going to reduce the trim from 1.5 by the stern to 0.963 of a metre by the stern. That's why we have to pump it in that direction, and it's this formula. We know the change of trim, weight times distance over MCTC, we know the MCTC, we know the distance to move the liquid between the tanks, therefore that's the value we're looking for, the weight, and that's how we would solve that problem. Often if you're unsure with problems like this, write down the formulas that you have to use, look at the information you've got and what you can put into the formulas, and often that'll help you to solve the problem in the right order.